We are now moving into our next presentation session from SLM and KAM on high productivity in additive manufacturing. I have joining me Winthrop, Sheldon, VP of Sales and Marketing, Americas of SLM, and Scott Volk, Strategy and Innovation at Keselowski Advanced Manufacturing. Scott, if you don't mind muting yourself for just 1 second.
Doing what?
There's a little bit of a playback. If you don't mind muting yourself for just 1 second.
Oh, I didn't even.
Perfect. Winthrop has a rich background in 3D design and manufacturing tools. Winthrop's experience with metal additive manufacturing started in 2013 when he joined SLM Solutions, and he has worked with many of the early adopters of the technology in the aerospace, defense, and energy industries. Currently, Winthrop leads the sales and marketing teams in the Americas region for SLM Solutions Group. Scott Volk is an industry expert in both the metal and plastic additive manufacturing industries with over 25 years experience. At Laser Modeling Inc. in Micron Technologies, Mr. Volk aspects of SLA and RTV processes, including materials development, quality, training, and estimating. Mr. Volk was one of the founders and vice presidents of manufacturing at GPI Prototype, with extensive experience in researching and development in laser powder bed fusion. Prior to joining KAM as Chief Technology Officer at Encodema 3D, he was responsible for all aspects of laser powder bed fusion, including manufacturing engineering, continuous improvement, risk assessment, and certifications. Welcome to both of you. Thank you for joining.
Thanks, Andrea. It's a pleasure to be here.
And if you have a screen share, you can press the button at the bottom.
Okay, there you go.
Perfect. I'll let you know when I see it, just to make sure you're good. Looks great. You can unmute, Scott. Thank you so much.
All right, thanks very much, everybody. It's a pleasure to be here this morning. Again, my name is Winthrop Sheldon, and it's a pleasure to be joined by Scott Volk from Keselowski Advanced Manufacturing. I wanted to go ahead and start our presentation today with a short video. So I believe Janet will play that next, and Scott and I will go onto mute.
And Winthrop, please mute yourself.
All right, very good. Janet, just a AV check. I'm back to my opening slide.
You're all set.
Perfect. All right, I wanted to start with a brief introduction on SLM, and my intention is to give you familiarity with our company and our technology, and then Scott will go into some more details about the one of our key customers, how they're utilizing our tools. So SLM Solutions is an OEM. We build metal 3D printers. We're based in northern Germany near Hamburg. This is an image of our factory. This is our facility where all of our activities are performed related to developing the equipment, developing our process, as well as all administrative functions. All executive leaders of our company work out of this facility, and this is where the printers are built. We have a number of subsidiaries around the world. The largest is here in the US. We also have them in China, as well as other regions. And we also have many distribution partners around the globe that support our customers and help us sell the equipment to prospective customers around the world. So SLM is known as a technology pioneer with the selective laser melting technology. Our first patents in the area were completed more than 25 years ago in 1996. We're also very proud to have Mr. Dieter Sforza still on our team as one of our leading engineers related to the selective laser melting process. He's the original patents are attributed to him. We're the first to market with multi-laser systems. So this is an area of technology that we're very familiar with. Our first twin laser system came out almost a decade ago in 2011. That was a 2-laser SLM 280. And then our first 4-laser machine, the SLM 500 model, came out in 2013. This is an area that we've spent extensive time developing our technology, as well as supporting customers in industry utilizing the benefits of this technology. And all of our machines, we focus on productivity and quality of the built product. We utilize a 2-directional recoating process in our machines, which minimizes the layer-to-layer time. We utilize multi-laser overlap stitching, which enables multiple lasers to work together to build one part, which provides the owner a significant increase in productivity. And we also focus on the gas flow in the process chamber to ensure that we have the optimal conditions for the best additive process. We do all of this with systems that are focused on safety, as well as offering closed-loop powder handling, so the operator and the people that are involved with operating the equipment remain safe and separated from the powder itself. So briefly, here's our machine lineup. You may have seen many of these machines around the industry. We're very excited about the relaunch and the latest version of the SLM 500 machine. It was launched at Formnext last year. We're also very excited about the introduction of the SLM 800 and the first units of this machine starting to make their way across the pond to the US market. We have about 6 of these machines slated to be installed this year. So as we focus on high productivity, this is one of the key attributes of our technology. One of the areas that we look at is the laser power that you can opt for in the machines. Here's a basic comparison of a quad laser SLM 500 machine running 400 watt lasers with the bar graph on the left versus for quad 700 watt laser machine on the right. You can see the comparison on this very basic geometry, these sort of cylinder geometries, 8 of them on an SLM 500 plate, building at 113 cubic centimeters an hour versus 171 cubic centimeters an hour with 700 watt lasers. So a clear benefit from an increase in laser power. The next attribute that we look at for driving productivity is the layer thickness that you're printing with. As many of us know, the height of the part that you're printing is a key driver of the print time that it will take to complete the print job. So here's a table comparing printing with 30 micron layers on the left side of the table with 400 watt lasers to gradually increasing to 90 micron layers, so tripling the layer thickness and moving up to 700 watt laser power. I love this image on the right because it shows in the same number of hours, so in 52 hours, how much of a print job we were able to complete with the 60 micron 400 watt parameter set on the left, getting about maybe 2/3 of the way through the job, versus the 90 micron layer thickness with 700 watt lasers on the right, showing that you in 52 hours you completed this this component. My last slide here on productivity is comparing number of lasers. For many of us in DMLS or SLM space, it's obvious the benefits of adding lasers, but for others it may not be as clear, and I hope this chart helps with that. You can see here the number of parts per build plate that we're able to produce on different machines. So you see an SLM 280 in the 2 left columns, SLM 500 on the right. You're comparing here a single laser machine to a twin, then onto a quad, and you can see a near doubling of the part count, a near savings of half the print time when you move up to 2 lasers, and then again nearly the same print time, but again you're printing double the components, so your print time per part is is half with the SLM 500. So from there, I would like to share just a brief video of the SLM 500 in action. This is a quad laser system. So this is, again, running 4 lasers in a row with 3 overlap areas, as well as this machine runs a right to left gas flow. So the gas flow is streaming from the right hand of your screen to the left. And it's highlighting also the 2-directional recoding system. So that unit that you saw moving is the printer head or the recoder. And this is depositing the powder for the next layer. And as you can see, every time the recoder is moving in an SLM machine, it's depositing the next layer of powder that will be lased and melted. And so with that, out of respect of time, I will conclude my section and pass the presentation to my colleague, Scott Volk.
Well, thanks, Winthrop, and thank you all for having me here today. Allow me to introduce Keselowski Advanced Manufacturing. I guess I got to do that first. You're all good? You can see that?
Scott, when you share screen, make sure you click into the window and then share screen.
And you can hear me okay?
We can hear you fine.
Okay, good. Okay. And you can see that?
No.
This is fun. You can see that?
No.
What the heck?
So, let's see. If you want, I can host your presentation and help you flip your screens if you want.
Except I never sent it to you, so you don't have it. You don't. That's weird. You're not seeing the presentation come up like that?
No.
And you're not. Are you seeing my screen at all?
No, we're not. Is your screen in a box right now in front of you?
No, it's not.
Okay, so click share screen and then click application window and select the application.
Yeah, that's what I'm doing, right? At the bottom toolbar, click on.
Yeah, click on share screen, a pop-up shows up. And
And my share screen is green. Oh, I'll do this again. Yeah, it's not toggling on or off when I click share screen. It goes green and then it stays there.
Oh, seems like we might have an issue here. So.
Do you want me to share the slides you shared with me last night?
I've edited them, but I guess we can use that. And I can work my way through it. Because it's a PowerPoint, so it's going to be huge, and I won't be able to send it, unfortunately.
You can send me a PDF version, and I can flip through it. PDF for you.
All right, sorry everybody. I'll have to save this out and send it. And that's Roxanne talking?
Yes. Yeah.
Scott, no, that was actually Janet, but we're both here available to help.
Okay, okay. Oh boy.
Thanks everyone for holding tight. Really appreciate your help there. Great.
I figured. Yeah, I'm happy to take any questions if there are any right now.
Oh, you have a lot. All right. In SLM, what is the difference in surface roughness when printing in 60 micron versus 90 micron layer?
That's a great question. Obviously, it's very geometry dependent, and the area of the geometry that you'd measure on. It also very dependent on the material. We actually haven't seen significant differences in roughness with aluminum, but it is an area that is, again, highly variable. So that's a great one for, I think, some of my applications colleagues who probably share some specific data. I don't have any offhand that I can share, but it is an area we'd be happy to show data that we have on hand.
Super. Another question that came up, while the increased number of lasers recoat time still remains the same, why would the time remain the same in twin and quad laser? And Scott, I just got your presentation.
Yeah, and actually I just figured out what the problem was.
Oh, it works. Wonderful. Okay, great.
It's a great question. The time is the same because basically between a 280 and a 500 machine, you're doubling the print area, and then you're doubling the number of lasers. And so you're getting almost 2x the number of parts with doubling the same number of lasers. So the print time remains the same, but the productivity doubles.
We'll begin Scott's part of the presentation. Thank you.
So now we see that, right?
Yep.
Okay, good. All right, so thanks again for having me, and allow me to introduce KAM. Our vision is to be a leader in the fourth industrial revolution through the use of simulation and advanced simulation, advanced manufacturing and CNC technologies, and a full suite of engineering solutions. We're a fully vertically integrated factory, primed and ready to serve production needs with aerospace quality and motorsport speed. We feature a world-class facility with multiple business units: simulation and engineering, advanced manufacturing, metrology, metallography, and CT scanning. With multiple additive manufacturing and CNC machines, along with our metrology materials testing lab and non-destructive testing, we're able to offer aerospace quality with motorsport speed. Here we have several of our equipment. You can see here we have multiple additive machines. Several EOS machines, an SLM 280 with dual lasers, which is what we're going to be talking about today, and also a concept laser M2 machine. All of our machines, one thing to note, all of our machines are dedicated to materials, which is actually a pretty hard thing to maintain, but so far we've been able to do that. No expense was spared by Brad in providing a positive workspace. Here you can see our conference rooms and office spaces. In our engineering center, this really provides a cross-communication environment for our teams. And our internal external training area is good for sharing lessons learned and also helping customers and community understand how to utilize advanced manufacturing. We do offer, if you guys want to talk about it later, a training program through this center as well. Some of the solutions that we've been able to utilize and learn using SLM Solutions. The additive manufacturing technology in itself, even aside from SLM, it's on its own, but through the laser powder bed fusion technology, we've really been able to advance through prototyping challenges of, throughout history, prototyping has been very challenging. And I think most people who understand additive manufacturing know that, this technology has really helped the world advance through prototyping challenges. Our progression utilizing the SLM technology has really helped us understand the throughput that we could utilize on this equipment. And I'll get into some of the build envelope stuff later. Being able to work from differences of design for additive manufacturing versus design for production is really important. I could talk more about that in the questions and answers section, but there really is a difference between the two. Size-related efficiencies and challenges. This is, the parts. When we looked at the SLM technology, the build envelope really suited this particular application and helped us as far as airflow, multiple laser utilization. It just really lent itself to this application really well. This is an example of the heat exchanger that we're working through. Obviously, it's not the real part, but you can see there's multiple layers of intricate heat exchange elements throughout the part. And one big challenge in parts like this is powder removal. And so the surface roughness that these machines provides is really helpful in the removal of the powder in these parts. The build volume, as I alluded to earlier, in the other powder bed fusion machines, we could get the parts in there, but with the SLM technology, we were able to get a few more in just the lower, the 280 size platforms. And as we were, looking at quoting the production on this machine, the throughput was great as far as the multiple lasers and the 700 watts. But when we looked at the SLM 500 and being able to transfer that learning on the SLM 280 700 watt, moving on to the SLM 500 with the multiple lasers at 700 watt was, as Winthrop showed earlier, the throughput was just too much for us to not pay attention to. And again, with the build envelope, as you can see here, really suited the heat exchanger. So we don't really have any wasted area. The airflow really lent itself to this application. And in this case, we really didn't have the stitching and overlap regions to really consider. We were able to utilize all the lasers without having any overlap regions with the way these parts were able to lay out. So kind of in recap, taking the SLM system with the two 700 watt lasers, these machines, once they're installed, they're really quick to get up to print readiness. The calibration, once the machine's installed, we really didn't see any drifting with the calibration, which is important with multiple laser systems. Also with the laser alignment was really true to form. And all of this really helped us with surface roughness. So the parameters that SLM provides were really good on the surface roughness, which really helped us remove the powder out of the parts. And, we really noticed a good run-to-run consistency on this machine. So, when we're looking at moving into production, this is really important. We do have the CT scanners and we're able to verify the removal of the powder, but, it's really important to be able to not have to be too concerned about that and being able to remove the powder. Also, and then looking at the 500, with the multiple 700 watts, as I said already, it really lent itself as far as geometry to that. One thing we're looking at is we are looking at the 800, the expansion into the larger build volume. This machine is the same as the 500 in the X and Y, but going into Z at multiple, we did see that we could stack these at 3 layers. So we could really get a lot of parts in the 800, and it's something we're looking at. And that's what I've got on that section. I really want, Winthrop and myself really wanted to leave ourselves open to questions and answers. So I hope we were both able to keep that relatively short to allow you to really get into the questions.
Great job, Scott. I think we have some time.
Thank you, Winthrop and Scott. All right, so we will begin on our questions. First up with the most votes, can we print floating without supports or point support metal parts with SLM LPBF printers?
Go ahead, Winthrop.
So we don't purport to offer that as a standard feature. I think there are some strategies you could deploy that would allow you to print floating. However, we would typically use at least some sort of small anchor support or taper apart such that it did connect to the build plate, simply to ensure that subsequent layers the lasing was occurring in the right location.
Thank you, Winthrop. Next question from Peter Rogers. I saw in situ monitoring being shown off at Formnext last year. Are you guys working on having real-time feedback loops to optimize tool paths and laser perimeters based on these monitoring results?
Yes, that's under development right now in Germany. Right now we've got laser power monitoring and melt monitoring as standard features. They're optional features for the machines, but the feedback loops are in development.
Awesome, thank you, Winthrop.
One of the issues with feedback loops is they can cause a denigration of performance, both to collect the data, but also to be measuring it in real time. So there is a trade-off to be had with real-time control today.
I can comment on that too. I mean, it's not feedback loop that I would initially talk about, but you know, in proper preparation of the build and using advanced simulation ahead of time, you know, the simulation tools today are just really, really good. And if you have an engineering team who's really utilizing them to the fullest, it really, in our view, it really limits the need for the feedback loop the way we have traditionally looked at it. It really does help if you prep your builds well. You don't have the recoder crash issues and the things that you would want to stop the machine and correct for. So it really helps in that area.
Thank you, Scott. Scott, could you tell us why did you select two manufacturers, EOS and SLM? Couldn't either one provide you the solutions you needed?
Absolutely. I mean, both could actually provide a good solution to this. In this case, like I said, really the main difference for us, I mean, you know, certainly a 404 by EOS could definitely be a build envelope, and with the multiple lasers could probably be similar to the throughput. In this case, really airflow is the main difference. When we look at the build envelope on this particular project and the way the airflow flows across the build and not having a large 16 by 16 inch area to really take into consideration for that airflow, it really lent itself to this particular application.
Okay. Next question. Is there a quality reduction where the laser melt pools overlap?
I'll let Winthrop answer as well, but you know, from a user point of view, we really don't see, you know, I know there's a lot of people in the industry who are concerned about this, and you know, to tell you the truth, the real telltale on this is really laser alignment and calibration. As long as you're monitoring your laser alignment and calibration, any of these systems with multiple lasers overlapping are manageable, and you can produce good quality parts.
Yeah, absolutely. So this is a key area of our technology. It's actually the way that we stitch together the lasers, and the layer-to-layer processing is a key element to avoid any quality issues based on the lasers building together on one part. So we have plenty of data supporting that, and the vast majority of our machines are sold with multiple lasers. So it's a core area of our product offering. We actually have a in-depth webinar topic covering that later today. So if anybody's interested, they can find that on the web.
Awesome. And we'll end with one final question. Top voted, can we print floating without supports or point support metal parts with SLM laser printing bed fusion printers?
So we kind of addressed that already, but I'll field it this time. Yeah, certainly. In any one of the laser powder bed systems, you can build floating parts and point supports. Really, the main concern, depending on technologies, is the recoder. And so, you know, there are systems on the market who tout being able to do this better than others. And if you look into those technologies, it's the recoat technology that really makes it possible or more possible. But certainly, you know, if you put the work into parameter development and simulation, pre-build simulation, you can definitely build free-floating parts and things like that within any one of the systems.
Perfect.
Yeah, absolutely.
Go ahead, Winthrop. Sorry.
I was just going to comment on the question, I think that actually hopped above it, which talks about the effects of laser power having on the melt pool geometry. And one of the nice things about the higher power lasers is that you don't have to necessarily drive them at full power. So you can vary the power between like the contour, which is the external area of the part, versus the core or the fill, and vary, you know, how you're using the power. So you can still do very fine features, but still benefit from the increased power on the thicker part of the geometries.
And I noticed we weren't able to cover all the questions, but you know, I think Winthrop and myself, we both SLM and KAM have independent tables. So feel free to afterwards come and sit at our table and ask us those questions.
Perfect. Thank you so much, Winthrop and Scott, for joining us today and presenting. Looking forward to connecting at the virtual networking later on.
Thanks, Adara. Appreciate it.
Thank you.